Hi everyone and welcome to this video about functions. In this video we're going to learn how to identify and then notate functions. Before we begin, please remember to like and subscribe if you enjoy the video, and if you have any questions about the content of this video, please leave them down in the comments section below. If you would like me to do another video on a maths topic of your choice, please comment that underneath this video too. To understand functions, we first need to understand the idea of a mapping. Now, much like real-life maps, mappings in maths are a way of getting from one group of numbers to another group of numbers. So let's say we start with the numbers 1, 2, and 3, and we find that these go respectively to 2, 3, and 4. So we can see that a relationship exists from one set of numbers to the other, and this can be represented by a mapping, which is that x goes to x plus 1. This sort of mapping is called a one-to-one mapping, and we can see this is because for every one starting number, we finish with one final number. Other sorts of mappings exist. We could start off with this set of numbers and find ourselves finishing with these numbers. We can see that this mapping here could be represented with x goes to x squared. However, in this case, it's not one starting number that ends with one final number. It's many start numbers going to a shared one final number. And finally, we have the case where we might start with one number, but finish with many numbers. This would be represented with the mapping x goes to plus or minus the square root of x. And of course, this is a one-to-many mapping. Functions are a subset of these mappings. Functions include one-to-one and many-to-one mappings. A function takes inputs, operates on them to give a single result. For one-to-many mappings, we get multiple answers for every input, so these are not classified as functions. One easy way to test if a graph shows a function or not is to use a vertical line test. Let's say we have the function that gives this line on my graph. The vertical line test is exactly what it says on the tin. We draw a vertical line, and then we investigate whether there is one intersection point or multiple intersection points between the graph and my vertical line. If there's only one intersection, it means that we have a mapping that finishes in 1. So it's either a one-to-one function or a many-to-one function. In this case, we can see that one value of x gives one value of y. So this is a one-to-one function. Let's take a look at the graph of another function. This is a quadratic function here. We're going to apply the same vertical line test, and we see that there's only one intersection. We need to use the vertical line on all parts of the graph to test whether it's a function or not. So this graph here, at any position, my vertical line only intersects once, therefore it can be classified as a function. Whereas something that would draw the graph of this, if we were to apply the vertical line test, on the left-hand side we can see there's only one intersection point, but when we move the vertical line to this position, we can see that there are now multiple intersections, and therefore this is not a function. Let's take a look at function notation now. Remember that for every input we're only going to get one output for our functions. So we can represent a function that doubles like this. Inputting a number like 4 would output a number 8. We can also start now to represent the inside of these machines with a letter. So instead of writing times 2, we can represent that with the letter F. Now, of course, we don't want to be drawing boxes and writing arrows all the time. We have a neater way of writing what this function is. We take our letter F and define it by giving it an input. In the case here that we're putting 4 in, we would get 8 out. F is the letter that represents our function. The bracket showcases what we're inputting, and on the other side of the equation is the output of the function. Let's generalize this even more. Let's say we put the letter x into our function. This function doubles its input, so what we get out will be 2x. Writing that in our function notation, we define the function f as the thing that takes in x and outputs 2x. So this line here is how we would normally see our function written and defined. We take the most general case where we put the letter x into the function, and we see on the right-hand side of this equation what the output is. In some places, you might see this written as f colon x, an arrow, and then the output. This is a lot less common than the first way of writing it, and from now on I will be using the brackets. So here we're given the function h of x. Now remember, it doesn't have to be the letter f that represents our function, it could be any letter in fact. So h is the letter that represents this function. The brackets show what the input of my function is, and the right-hand side shows me what the output would be given that input. So we can backtrack a little bit and try and figure out the steps that are being applied to the input. We see that the first thing that happens is a times by 3, and then the next thing that happens is a minus 2. So we take our input, we multiply it by 3, and then we subtract 2. Remember, it doesn't matter what the input is. The function itself doesn't depend on the input. The function is just the process that happens to it. So looking at this first question, this is asking us, what would the answer look like if my input was 2? So I take my function, I replace my input x with input 2. So on the right-hand side, wherever I had an x, I'm now going to replace with 2. When I do this, I'm being mindful to keep it in brackets. This is a technique that I suggest you use because later on when we're inputting more complicated expressions, the brackets will be helpful. So instead of x, I have 3 multiplied by 2 minus 2. This is going to give me 4. For part 2, instead of the old input x, I'm now inputting y. So I'm going to take my y, times it by 3, and then subtract 2 from it, giving me the expression 3y minus 2. Let's look at our second example. So the function this time is much more complicated. We're taking the input and we're doing several things to it. We're squaring the input here, and here we're multiplying by 2, and finally we're summing together both of those answers. So the technique stays the same. For part I take my input, which is now 3, and replace any of the old x's inside of my function. So instead of squaring x, I'm squaring this 3. Instead of doubling the x, I'm now doubling the 3. Simplifying this, I get 15. For part 2, my input has now become x plus 1. So the technique, just because it's algebra, does not change. Wherever I used to have an x, I now replace with the bracket x plus 1. So it becomes x plus 1 squared plus 2 times x plus 1. And now I can simplify this. Moving on to part 3, I take my input, which is now y squared, and replace where the x's are in the function. So instead of x squared, it's now brackets y squared squared plus 2 times y squared. So you'll see how I'm always putting brackets around what I'm replacing x with. This makes sure that I don't go wrong when I'm doing my expansion and simplification. And there's the final answer. Looking at our third example, for part I, we can see that here f of x stays the same, except we've got a 2 in front of the f of x. This 2 is multiplying the entire function. So instead of substituting into the function, I'm now taking the function and applying operations to it. So in order to do this, I'm going to take f of x, place that in brackets, and now apply whatever operations are being done to f of x. So here, it's just a simple multiplication by 2, giving me my final answer. For part 2, here, the 2 is multiplied inside the bracket. So I have to change what the input of my function is. It's no longer x, it's now 2x. Instead of x, I replace it with this bracket of 2x and get my final answer. For part 3, again, nothing is happening to the function itself. The difference between part 1 and part 3 is that in part 1, stuff is being done to the letter f. The function itself is being multiplied by 2. In part 3, nothing is being done to the letter f itself. Things are happening inside the input bracket. So instead of inputting x, I'm now inputting 2x plus 1. Remember to retain the brackets, square that, and then we subtract the input away again, leaving us with our final answer. Let's take a look at another example. In this case, we have 2 functions defined for us, p of x and q of x. The question asks us to solve the equation p of x equals 2 times q of x. For p of x then, I can just replace that with the function. On the right-hand side, I'm multiplying q of x by 2, so I'm going to do 2 times by q of x, replacing the q of x with the fraction 1 over x plus 4. Let's expand. So this becomes now an algebraic fractions question. We can times both sides by the bottom of both fractions, and so we get our final answer, x equals 2 over 3. In this example, we took our functions and we created an equation in order to solve for the value of x that satisfies the condition given. This is our final example. So on the left-hand side of my function equation, I have g of x plus 1. The input of g is no longer x, it's been replaced with x plus 1. So we go back to our function g, and wherever we had an x on that right-hand side, we're now replacing with the input x plus 1. On the right-hand side, h of x hasn't changed, so we replace h of x with the right-hand side of h of x. Finally, we're adding 1 to this expression. Simplifying both sides, we get this expression. Now we can square both sides, set up a quadratic, and solve for x. We find that this gives us the solutions x equals 3 or x equals minus 1. Let's double check that both of these work. Well, going to g of x, we see g of x has a square root. Now this square root means that nothing inside the square root can be less than 0. We can't square root negative numbers. If we try to input minus 1, we would find minus 2 plus 1, which is minus 1. We can't square root minus 1, therefore x equals minus 1 can't be an answer, and so our final answer is x equals 3. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comments section below. Please like and subscribe if you enjoyed it, and I will see you in the next video.